Welcome to One Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 66. If you didn't watch previous episodes, I encourage you to go and see. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal contains the bicyclic system with alkene inside and exoalkene also there. Then you have CH2Br. Reagents are magnesium and carbon dioxide and hydrolysis. Then you are using COCl2 and base triethylamine. Here products are given. Products are different cycle chain and different cycle length. So 3-member ring, 4-member ring, 5-member ring as well as epoxide. From the starting metal and possible products, you might understand that the carbon skeleton change definitely occur and new CC bond form there. The answer is D. Let us see how. The starting metal contains methylene bromide and you have magnesium. What really happens is it forms Grignard reagent. So MgBr formation will be there. Then the next step you are using the CO2 and hydrolysis condition. Then you have the CH2 attack the CO2 and you got the COH group there. So Grignard reagent get into the acid formation. Then next step you are using COCl2. So what happens is OH becomes Cl there. Just chlorination occurs there. Next step you are using the base. So what really happens is base abstract the proton and you have anion formation. Chlorine is a good leaving group, you have anion formation. So CC double bond is formed there. It's a kind of ketene. Then you have ketene and equal and parallel double bond. Then you might expect 2 plus 2 cycloaddition. So new 4-member ring will be formed there. So if you rewrite clearly, you will get D. Here you have to learn 2 important things. One is whenever you look at the reagent, always possibility of functional group transformation. Particularly Grignard reagent to acid, acid to acid chloride. Then if you have good leaving group, you always think of leaving that group. So the charge quenching always achieved by pushing out the leaving group. Then the question number 2. The starting metal is linear chain with many functional group alkene, amine, alcohol and alkane. Here reagents are like pyridine aldehyde and para acid, benzene in heating replace condition. They ask you to find the product. The products are mostly pyridine substituted 5-member ring and which way the reaction happens is a real question. Whether the ring is attached in first position or second position or the carbonyl position or 1 or 2 in the 5-member ring. So you have to understand that from the reagent it's a naming reaction and a naming rearrangement also there. The answer is A. Let us see how. Here you have alcohol and you are using the amine. So obviously you think of manic reaction. Manic reaction, what really happens is C double bond N formation will be there. So during the manic reaction, new CN double bond is formed there. Then you have possibility of rearrangement since you have double bond. So you think of the rearrangement. Since it's contain amine, you might consider Asakop rearrangement. It's a 3,3 sigmatropic rearrangement. So double bond moves, new CC bond occurs there. The chain will be open at the end. Again you have to think of cyclization because cyclization is the stable one. Cyclic product is very stable. As well as the charge of nitrogen has to be quenched. So what really happens is new CC bond occurs there. You got the new 5-member ring with aldehyde. So the alcohol get into aldehyde there and bond slips occurs. So the product is clearly A. Here you have to learn 2 important things. One is Manich reaction. Manich reaction, what really happens is condensation of alcohol and amine. You got C double bond N. Then you have Asakop rearrangement. Asakop rearrangement involves nitrogen, but it is a normal 3,3 sigmatropic rearrangement. Then the question number 3. The starting metal is cyclohexyl system with alkene and side chain contain alkene and iodide. We are using the reagent palladium and silver carbonate. The products are given. The products are mostly double bonded compound. The position of double bond is real question. Whether it is on the fused ring or it is away, or position of hydrogen or methyl group also the question. So from the palladium reagent you might guess it's a naming reaction, and definitely selective double bond addition is occurred there. The answer is A. Let us see how. You are using palladium acetate and phosphine and you are having iodine in the starting metal. So you might expect it's a Heck coupling. It's just a coupling reaction. So initially palladium with phosphine form palladium phosphine complex. The formed complex will be used in the system where you have iodine. So the complex balance itself and form the addition reaction there. Then next step ring closure is occur. Ring closure is a direct addition of double bond. Normally 5-exo cyclization is the favorable one and it is a syn addition. So the bonded form below the one palladium in the system. So palladium has to be removed. Palladium can be only removed by beta hydrogen. Since it's a metal, beta hydrogen removal is possible. So beta hydrogen eliminates that, you have new double bond. Here you might expect why the double bonds in the ring position or the fused position not attacked there. Because the Heck coupling always not occur in the quaternary or tertiary stereo centers. If you are interested, go and study intramolecular Heck coupling. And beta hydrogen elimination is a syn elimination here. So you have hydrogen and methyl is above the plane. Here you have to learn two important things. Whenever you have alkynyl iodide and palladium catalyst, you might think of Heck coupling. Then the ring closure is exocyclic reaction and only the beta syn hydrogen elimination occurred here. Then the question number 4. The starting metal contain ether attached with two big rings. One is benzene attached with cyclohexane, another benzene attached with methoxy group. You are using the DDQ one equivalent. Next step you are using phenyl iodine acetate. It's a multivalent compound of iodine. Then methanol. They ask you to find the product. The products are mostly the cleavage occur in the oxygen. So where the cleavage occur is a real question. Which compound survive also the real question. So the question is all about two special reagents, DDQ and iodine multivalent compound. The answer is B. Let us see how. The starting metal you have attached system which is para-methoxybenzyl. It is a protecting group which is normally called BMB. So we rewrite it. Normally used to protect the alcohol. Protecting means the functional group will not participate in the reaction. So OBMP is there. Then the next step you are using DDQ. DDQ selectively remove BMP. So you got alcohol again. So deproduction normally occurs there. So you form the alcohol. Next step you are using the iodine reagent. So what really happens is the alcohol attack on the iodine, acetate leaves there. So acetate leaves, you have the remaining acetate on the side. Then you are using the methanol. Methanol attacks on the possible carbon. Then you have charge transfer and you have the ketone there. So it's a kind of oxidation condition. It's a mild oxidizing agent. It always involved in the formation of quinone. The reagent specialty is quinone. So here you have to learn two important reagents. One is PMP. PMP used to protect the alcohol and it can be deprotected by DDQ. DDQ is dichlorodicyanobenzoquinone. Second reagent is iodine phenyl acetate reagent. It is a kind of oxidating reagent. It always favors the quinone kind of architecture. Then the question number 5. The starting metal contains 3-member ring with acetate and benzyl group. Then you are adding with long chain system with ODPDMS and ketone which is in the conjugated ketone. You are using the heat and toluene there. Here 4 products are given. 4 products are 5-member ring. The reactant is 3-member ring. Here it is a 5-member ring. Then the position of TPDMS and the methyl groups in the real question. So where it will attack, where is the possible product is the real question there. So you have to understand that the intermediate form here is important and regioselective ring closure is occurred here. The answer is C. Let us see how. The starting metal, you have the 3-member strained nitrogen system. So you are using the heat. So it needs just trigger to open the ring because of its strain. So ring is open, you got strained 1,3 dipolar molecule, which is cation and anion in the same system. It's a dipolar in 1,3 position. Then you are adding alkene. Alkene fused with the system, you have new 5-member ring. The new 5-member ring, here cyclohydrogen reaction is the concerted reaction. So you have the same trans relationship maintained there because 1 and 2 is trans, product also trans, as well as you have DP-DMS carbon and Ester carbon also below the plane. So you have to maintain the relationship here. Here the fact is that ring opening prompted by strain and stabilization of negative charge there. The ring can be open in the either way, but the anion form near to the acetate because of its stabilization. So anion forms near the acetate is the electron withdrawing group. The negative charge formed at alpha carbon. Then the attack can be on 1 and 2. Why the attack is happening on 1? Again the same thing, negative charge is stabilized if attack is happening on 1. That's why the reaction is regioselective. So here many factors are involved in the single question. By looking at it, it's very simple, but thinking wise it is very different. Here you have to learn 2 important things. One is the stability of carbon ion always plays a role throughout the reaction. First step, it decides the ring opening. Second step, it decides the regioselectivity. Then the ring closure always happen in the concerted way. So the stereochemistry is preserved here. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.